We're in section 5-6, and this is going to be pretty strange. The issue is we have something in the form x prime is equal to ax. We're going to find the eigenvalues, then we're going to find the eigenvectors, we're going to have initial conditions, and the initial conditions are going to be at 0. So if we don't have initial conditions at 0, this isn't going to work. So x1 at 0, x2 at 0, x3 at 0, whatever they might be. We have to have those two, for as many as there are. Now once I have them, what we're going to do is say that iota of t is going to be equal to the answer. So that's the eigenvalue and eigenvector. Eigenvalue, eigenvector. And we might have 3 or 4 or 5 of these, who knows. We'll just go with 3. So is equal to that. And then once we have that, then we're going to say that x of t is going to equal the iota times iota inverse at 0 times the initial conditions at 0. Okay. Well, and when we get done, we're going to have all the constants C1, C2, C3 are going to be all solved for in our final answer. So it looks like a little bit too much work to get an answer. It looks like I ought to be able to do something easier than that. But that is this section, and that's what we're going to do. So we're going to start with number 2. And I have x prime is 2 minus 1 minus 4, 2, x. And I have my initial conditions at 0 are going to be 2 and minus 1. Okay. And so now we see that what we need to do is we need to come up with the eigenvalues. So the determinant 2 minus lambda minus 1 minus 4, 2 minus lambda, and I've got 2 minus lambda squared minus 4 is 0. And I see that that's going to come down to lambda, lambda minus 4 is 0, and my eigenvalues are 0 and 4. Okay, now we need eigenvectors. Case 1. Lambda is equal to 0. 2 minus 1 minus 4, 2 times v1 is supposed to be 0. And by inspection, I get that v1 is going to be 1 and 2, 1 and 2. 2 minus 2 is 0, 4 minus 4 plus 4 is 0. So that's my first one. Case 2, lambda is equal to 4. So I've got minus 2, minus 1, minus 4, minus 2. V2 is equal to 0, and I get that by inspection, V2 is going to be 1 minus 2, 1 minus 2. Okay. So that being the case, we have iota of t is going to be v1 e to the lambda 1t plus v2 e to the lambda 2t. And I have no idea what this dot is in front of that lambda. Okay, so that's what it is. And we'll write it one more time and say that's going to be 1, 2, e to the 4t, e minus 2, e to the 4t. Okay, well that seems like a reasonable thing to do. Now I'm going to look at iota 0. Iota at 0, and that's going to be 1, 2, 1 minus 2. And now I'm going to find the inverse of iota 0. Okay, so I got 1, 1, 2, minus 2, and I put it in a matrix with the identity matrix. And I want to turn this guy into the identity matrix, and whatever on that side is going to be the inverse. Okay, I'm going to go 2 times the top row and subtract it from the bottom row. So I got 1, 1, 1, 0, 0. 2 times that is 2. Subtract it from a minus 2 is going to be a minus 4. 2 times that is 2. Subtract it from 0 minus 2, 1. Okay, and then I'm going to go and multiply this guy by minus 1 over 4. And when I do that, I'm going to get 1, 1, 1, 0, 0, 1, 1 half, minus 1 quarter. All right, and then we're going to take the bottom row and subtract it from the top row, and I'm going to get 1, 0, 0, 1, and I'm going to get 1 half, 1 quarter, 1 half, minus 1 quarter. So I find that iota 0 inverse is going to be 1 half, 1 quarter, 1 half, minus 1 quarter. Okay, well that's good. Now I'm going to do a calculation that's going to be my final answer is going to be iota x, iota t probably. We'll go with t. Iota inverse at 0, x of 0. So So that's what I'm going to do. And so we'll come back up here and get this guy. I don't have to write him again. Copy. Go to the next page. Paste. Okay, so that's my iota at 0. 1/2, 1/2, 1/4, minus 1/2. And then x of 0 is 2 minus 1. Okay, so that's all I have to do. I'll go this way because it's simpler, I guess. X of t is equal to 1, 2, e to the 4t minus 2 e to the 4t. Okay. First row, first column. 1 minus 1/4 is 3/4. 1 plus 1/4 is 5/4. Okay. Then we'll write down a final answer. Final answer. X of t is equal to, we're going to bring the 1/4 out. 1/4, because that's going to be everywhere. And I'm going to have 3, and I'm going to have 5 e to the 4t. And then I'm going to have 10. No, I'm going to have 6. I have 6. And I'm going to have minus 10 e to the 4t. Make that look a little better. Okay, is that the right answer? And the answer is yes, that's the right answer. Okay, so that checks with the back of the book, and we will stop there and move on to the next problem. Now, I don't think that that's, I think that's harder than if I just solved it and then solved for C1 and C2. I mean, I don't see any advantage in doing this other than I can do it on a computer pretty quickly, I guess, because it's all numbers. Number 4. X prime is equal to 3 minus 1, 1, 3. Three minus 1, 1, 1. X. And at that point, we're going to pause for a moment. So I looked in the book, and I found that I do have the right problem, so that's good. So x of 0 is equal to 1, 0. Okay, so first thing I need to do is find the eigenvalues. 3 minus lambda minus 1, 1, 1 minus lambda is supposed to be 0. And what do I get? I get 3 minus lambda, 1 minus lambda, plus 1 is 0. And so I get lambda squared minus 4 lambda, 3 and 1 is 4 plus 4, is, that doesn't look like a 4, is 0. And I get my lambda as 2 and 2. Okay, well that is a horse of a different color. Now I have two lambdas that are the same, and the issue is, can I, how am I going to handle that? Well, we'll find out. Case 1. Lambda is equal to 2. Here, so I've got 3 minus 2 is a 1 minus 1, 1. And 1 minus 2 is a minus 1. And I look at that, and V1 is equal to 0. And I can find a V1, which is 1, 1. But I can't find another one. So that means I'm deficient. So that means I can't do that. So I have to take A minus lambda I squared V2 is equal to 0 and see what I get. And so if I square 1 minus 1, 1 minus 1, 1, 1, minus 1, minus 1. First row, first column, 0. First row, second column, 0. First row, second row, first column, 0. Second row, second column, 0. Okay, so I can basically pick V2 anything I want. I'm not going to pick V2 as 1, 1 though, so that would be a non-starter. I'm not going to do that. I'm going to pick 1, 0. Because that worked every other time I picked 1, 0. Why shouldn't it work this time? Okay, now I'm going to look at A minus lambda I V2 and figure out what V1 is. Okay, so A minus lambda I, 1 minus 1, 1 minus 1, 1, 0 is V1, which is going to be 1, 1. Okay, so now I have my two vectors that I need, and I've got x1, which is going to be v1, 1, 1, e to the 2t. And I've got x2, which is going to be v1, which is 1, 1, t plus v2, 1, 0, and I'll put e to the 2t. Okay. And so x2 is going to be t e to the 2t plus e to the 2t t e to the 2t. Alright, that's good. And x1 is e to the 2t, e to the 2t. Alright, so that being the case, we have a iota iota t is going to be e to the 2t, e to the 2t, we'll call it t plus 1, e to the 2t, and t e to the 2t. Okay, so I got my iota. Now I want to have iota 0. And now that's going to be a 1, that's going to be a 1, this is going to be a 1, this is going to be a 0. Okay, looking good. And now we're going to go and find iota inverse at 0. And 1, 1, 1, 0, 1, 0, 0, 1. We're going to take the top guy and subtract him from the bottom guy. 1, 1, 1, 0, 0, minus 1, minus 1, 1. Okay. Then we're going to take the bottom guy and add him to the top guy. 1, 0, 0, 1, 0 minus 1, minus 1, 1. And then we're going to multiply the bottom guy by minus 1. And we're going to get 1, 0, 0, 1, 0, 1, 1, minus 1. And we're going to say iota 0 inverse is 0, 1, 1, minus 1. Okay, so now we want to, I got come I went the wrong way. I think we put these guys in the wrong spot. Okay, there we go, that's better. All right, now we go to the next guy. Okay, so what we're going to do, we're going to have x of t is going to be iota of t, iota inverse at 0, x 0. That's what we're going to do. All right, so we have e to the 2t, e to the 2t, t plus 1, e to the 2t, t, e to the 2t, 0, 1, 1, minus 1, 1, 0. Okay, well, we'll keep the first guy for a little bit. And clean up our work. Precious little. Okay, now, first row, first column is a 0. Second row, first column is a 1. So x of t going to be first row, first column, t plus 1 e to the 2t. Second row, first column, t e to the 2t. So x1 of t plus 1 e to the 2t. And I'm not going to rewrite it over again. It's perfectly okay, and keep the answer that way. And it checks with the back of the book. And it checks with the initial conditions. T at 0 is supposed to be 1 up there and 0 down there, and it is. So that's good. Okay. So now we'll start with problem number 6. Okay. If you're not sitting down, you should do that now. We have 7, 4, minus 5, 3, x, and x0 is 2, 0. Okay, so now I need eigenvalues. 7 minus lambda minus 5, 4, 3 minus lambda. Absolute value, and I want it to be 0. 7 minus lambda, 3 minus lambda, plus 20. Is supposed to be 0. Lambda squared minus 10 lambda plus 41 is equal to 0. So I'm going to use the half quadratic formula. So I don't know that I've done that before. So a quadratic formula is normally minus b plus or minus square root of 2 of b squared minus 4ac over 2a, right? But if I change the formula to be minus 2 times 5, I can use a half quadratic formula and say that lambda is equal to minus b, which is 5, plus or minus square root of b squared, 5 squared, minus 41 divided by 1. 25 minus 41 is minus 16, so I end up with 5 plus or minus 4i. Okay, so now I need eigenvalues. I need eigenvectors. I have my eigenvalues. So eigenvectors. Okay, case 1. Lambda is 5 plus 4i. Okay, so I've got 2 minus 4i minus 5, 4 minus 2 minus 4i times v1 is supposed to be 0. So v1 by inspection. How about 1 plus 2i and a 2? 1 plus 2i gives me 10, gives me 10, minus 10. 1 plus 2i gives me 4i minus 4i minus 2 minus 4 plus 4. So that's good. Okay, well, except for 2 dots on the I, I'm all set. Okay, case 2. Lambda is equal to 5 minus 4i. So I've got 2 plus 4i minus 5, and I have 4 minus 2 plus 4i times v2 is supposed to be 0. So we look at that a long time, and we see if I had 1 minus 2i and a 2, then the same thing's going to happen. I'm going to get 0. So those are my 2 vectors. So that being the case, I have x1, which is going to be v1 e to the lambda 1t, which is going to be 1 plus 2i 2 e to the 5 plus 4i. And I have x2, which is going to be v2 e to the lambda 2t, which is going to equal 1 minus 2i 2 e to the 5 plus minus 4i. Okay, now I can bring out the e to the 5. So I'm going to rewrite x1. I'm going to rewrite it as e to the 5, and I'm going to have 1 plus 2i 2. And then I'm going to change e to the 4i to cosine 4t plus I sine 4t. And I wasn't really planning on having this be a complex variable class, but it's the last problem we're working in this set, so we might as well do that. x2, I'm going to bring out the e to the 5th, and it's e to the 5th t, e to the 5th t, and I left the t out of these guys, didn't I? T, t. Okay, that's better. I feel better now, and I've got 1 minus 2i, 2 down there, and I've got cosine 4t. Now, the cosine of minus 4 is the same as the cosine of plus 4, because cosine is an even function. The sine of minus 4 is minus, so I'm going to have a minus I sine 4t sitting there, because the sine function is odd. That's odd that I should say that, right? Okay, so that's what I've got. Isn't that lovely? Now let's see if I have enough room. No, I don't. So what I'm going to do is I'm going to find the real part of x of t. So I'm finding the real part, and I'm going to have e to the 5t, and I'm going to have cosine 4t minus 2 sine 4t, and I'm going to have 2 cosine 4t. Okay, so that's the real part of x of t. And then I'm going to put down the imaginary part of x of t. And I'm going to have e to the 5t. And I'm going to have 2 cosine 4t plus 2 sine 4t and 2 sine 4t. Okay, so isn't that just the most loveliest thing you've ever seen? All right, now what we're going to do next is find iota of t, and you're going to look through the book trying to find where the author told you to do this, and you're probably not going to find it, and it's going to be the real part of x of t and the imaginary part of x of t. So that's what you're going to do. And so iota of t becomes e to the 5t cosine 4t minus 2 sine 4t 2 cosine 4t, and then we'll change colors. 2 cosine 4t plus 2 sine 4t and 2 sine 4t. Okay, sounds good. And then we're going to look at iota at 0. Okay, so I got a 1 out in front. I got a 1, I got a 0, I got a 2. 1, 2. I've got a 2, I got a 0. 2, 0. Okay, so that being the case, I need to find iota have a need for iota at 0 inverse. Okay, so I'll take 1, 2, 2, 0. Now your graphing calculator will do this for you. So you can't do it my way, you can always do it that way. Okay, we're going to go times 2, and we're going to subtract the top one from the bottom one. 1, 2, 1, 0, 0, 4 times 2, it's going to be a minus 4. Minus 2, 1. Okay. Then we're going to go and do a times minus 1/4. Okay, and we got 1, 2, 1, 0, 0, 1, 1/2 minus 1/4. Okay, we're going to go times 2. And then we're going to do a subtract. And we're going to get 1, 0, 0, 1 times 2. That's a 1. We subtract it from 1, we get a 0. times 2, it's a minus 1/2. We subtract it from 0, we get a positive 1/2. 1/2 minus 1/4. So iota 0 inverse is going to be 0, 1/2, 1/2 minus 1/4. And if anybody gets this problem right, including me, it's going to probably be a message from somebody. All right, now, here we'll go to the next piece of paper. We want to do x of t is equal to iota at t inverse iota at 0 x0. So that's what we're doing. Okay, so I'm going to go back and find where the last place I had my iota. That's going to be here. All right, so there it is. So we'll copy it. I hope I got it all. Okay, we're going to get rid of the stuff there, and then we're going to move this guy over. Like that. Okay. Now I need my iota inverse at 0, which is 0, 1/2, 1/2 minus 1/4, and then I need my x of 0, which is 2, 0, 2, 0. Okay, so we'll do another edit paste because I want my iota guy back again. Thank you very much. Okay, we'll get rid of what's in front and move it over. Way to go. Total loss of control. Okay. Luckily you guys can't see what how I'm changing from erasers to whatever. Okay, now 2, 0, 1/2 times 2, 0 is 0. 2 times 1/2 is 1, and 0 times that is nothing. So that's what I have. Okay. So now that I have that, I can say x of t is equal to e to the 2t. That guy goes away, this guy goes away, all I have, and I got a 2, a 2, and a 2. I'm going to put a 2 out there and call this cosine for t plus sine for t and sine for t on the bottom. And with that, I just erased way too much. Plus sine for t, sine for t. And with that, we check the back of the book and we have the right answer, and life is wonderful. In section 5-6, the rest of it can be left to some grad student sometime in the future. when you take your second or third or fourth differential equation class, which will probably be a partial differential equation class anyway. Okay, that ends 5-6, and for that matter, chapter 5.